lecture. Hopefully you took a little minute to kind of get everything tallied up and finished up with the last little bit and made sure you understood it. Kind of just slightly changing topic or transitioning here, so we'll start a new lecture for that, so you can have a little gap in between and be forced to kind of withdraw what you and suck up what you took in the last lecture. So with this, we're still working with fractions here, but we're working on converting fractions to decimals because they're interlinked. Essentially, all it is a division. Okay, so all that we're really and truly doing in order to convert this fraction to a decimal is a division. Okay, so like for 29 divided by 100, all we're doing to convert that to a decimal is we're taking 100 and we're dividing that into 29. Okay, now 100 obviously can't go into 2 or 9, but it can go into 290 two times. And then we're going to bring this 0 down, and it can go into 900 9 times. So we can see that the conversion there is 0.29. Now, 29 out of 100 converts to 0.29. We're working in a base 10 system here, so hopefully that makes sense. If I had, say, a pie and 29 slices were selected out of all 100 slices total, I'd have 29 out of 100 fractionalized, or 0.29 as a decimal. Okay, so in order to convert from a fraction to a decimal, all we're doing is dividing the bottom number into the top number. Now going forward, especially in like Math 108, you will have a calculator, so conversion should be fairly simple. Actually, both direction conversion is very simple with the TI-84 because it has a button for both, where you convert from a fraction to a decimal and a decimal to a fraction. Okay, it has both of those capabilities, but you should know the underlying process behind. And hopefully with some of these fractions, you can convert them quite quickly into decimals. Okay, if we go into the second one here, we have 5 out of 10. 5 out of 10 here. And if we want to convert that to a decimal, okay, like I said, if we were doing the division method, we divide 10 into 5. Clearly it won't go into 5, so we add a decimal and a 0. It will go into 50 5 times, and we're done. Okay, so the decimal conversion here is 0.5. Now, you could also reduce that if you wanted to a 1/2, and you might know that 1/2 is the same thing as 0.5. Fair enough there. Obviously, if the pie had 10 slices, we were only selecting 5 of them, we'd be selecting half the pie if it was equal slices. Alright, let's see if we can convert this one, and let's see if you can see the trend here with some of these base 10 objects. Now, if you'll notice here, on number 2, that could have also been written as 50 over 100, right? Which would have given you the 0.5. Technically, if you took that out to the hundredths place, it'd be 0.50, which is the same thing as 0.5. So hopefully you can see by the time you get to number 3, this is simply 0.42. Now that's only if you're working with the base of 100, right? Or if you take the 10 and convert it to a base of 100. It's not as simple if you have like 42 out of even 50. But for base 10, all we're doing is dividing 100 into that. It's going to turn out this way, right? Alright, let's look at 1/10. Now, 1/10 you could convert into 10 out of 100 if you wanted to, which would just be 1/10 here, or 10 hundredths. And the key in that is seeing that this 1 is in the what we call the tenths place. The 0 is in what we call the hundredths place. Okay? Now, 1/10 means there's a 1 in that tenths place. Okay? Whereas if we had converted this, which we could, to 10 out of 100, that would mean that there's 10 in the hundredths place. So there's a 10 and it goes to the hundredths place. I've got 14 in the hundredths place here because we're dealing with a 100 base here. So it should be 0.14. I got a 3 in the tenths place. It should be 0.3. Okay, that's the beauty of working with the 10 and the hundredths as far as your division factors go there, and your fraction factors converted to what we would call decimals. We got 40 in the hundredths place here for number 7. That should as well be a pretty easy conversion. I think I lost my pen. Yeah, lost it a bit. And 4 out of 10 is essentially the same thing, because if you see 40 out of 100, Alright. Alright, so what I like to show here, let me change my pen color, is that with this simplification, if you don't know this trick, if you have 40 over 100, you notice that they both have zeros on the end of them. So if I wanted to simplify this, I could just cancel out those zeros. So this only really works for the tenths place, or for the tens or sections of tens here. But I'm basically just dividing by 10 on both fronts. And this reduces to 4 out of 10, which would be the same thing as number 8, which is just 0.4. And you can see that these decimals here, 0.40 and 0.4, are the same thing. Okay, so I don't know if you knew that simplification step there, but that's just basically canceling by a factor of 10. Let's do another one. Now 37 out of 100, that converts to 0.37. 8 out of 10, that should convert to 0.8. 45 out of 100, 0.45. 55 out of 100, 0.55. Simple, simple, simple so far. 96 out of 100 should be fairly simple, 0.96. 39 out of 100, 0.39. We're just converting from fractions to decimals. And now we're getting really cocky and confident with what we're doing here. Converting 7 tenths to 0.7 because we're in tenths place. We're back to the hundredths place with 8 out of 100. Now, this is where it gets a little different here. Okay, we've got 8 out of 100. That 8 needs to go in the hundredths place. Don't make a mistake and put it in the tenths place. It needs to go in the hundredths place. Remember, the hundredths place is that second decimal over. So 0, 8 is 8 out of 100. If I'd have put it right here where the 0 is currently sitting, then that would have been 8 out of 10. So be careful. It can get a little tricky. 62 out of 100 converted to a decimal is 0.62. 84 out of 100 is 0.84. 59 out of 100, 0.59. 2 out of 10, 0.2. And that's okay if you put zeros in front of any of these. 0 point, 0 point, 0 point's fine. You might see answers written like that. That's perfectly fine. Just to help highlight where that zero's at or that decimal's at right there. Some people do that. That's perfectly fine. It's correct either way. 70 out of 100. Here I'm going 0.70. And the only distinction I'm going to make here to kind of wrap this lecture up is if, let's say, for instance, I'm going to give you a handwritten number 22. If I had asked you to find the fraction of something a little more complicated, let's say 30 out of 50. That would not be 0.30, obviously, because you have a different denominator. For this, you would have to divide 50 into 30. Okay? If you divide 50 into 30, what you're going to see is it comes out with a decimal of 0.60. Okay? So, don't think you can just write the number that's there right on over. Okay, because your denominator might be different than a 10 or a 100. We started out with really basic stuff. But the whole premise behind this is you're just dividing the numerator by the denominator. And like I said, you will have access to a calculator to do this. So you're just dividing the numerator by the denominator to get the decimal. That's how you convert from a fraction to a decimal. Okay. A little bit of easy practice there, just a refresher of where fractions come from and how to do some really simple ones. Like I said, we'll leave the more complicated ones to the calculator because you will have access to it. But if you don't know why you're doing something or generally how you're doing something, sometimes it makes it harder for the connection later on. So I wanted to start with a simple one, show you where the simple ones come from, lead you to the process to do the more complicated ones so that you still know where they come from. So, I will see y'all tomorrow on our next lecture video.